Right, this will start the material for the second half of the semester. And we start with the endocrine system, which can be rather complex and we have a lot of different hormones, but I've tried to narrow it down to just a few hormones that I felt were more affected by aging, or maybe a little bit more important to understand with aging. And to begin with, and you notice the title here is Endocrine Type 2 Diabetes, because I actually spend more time discussing diabetes than I do the endocrine system. And if you'll actually also take note, this is one of the few disorders that I will discuss rather than a student. And that's because I didn't really feel it was fair to put that one on a student, because there's a lot of information that's common. And there's certain things that I wanted to make sure that you learned about it as well. So that is kind of a large part of the presentation here. So endocrine system in general, the tissues that make hormones, and I could say tissues and cells, right? But let's just stick with tissues. The hormones themselves, well, what is a hormone? It's a blood-borne chemical messenger. It's made in one cell type, gets into the blood, circulates, and then it acts somewhere else in the body, right? And we also in the endocrine system often talk about the target tissues, which ones are the hormones getting to and then having an effect. Now I've made this little table down below. It's fairly straightforward. The hormone on the left, where does it come from? Where does it go and what does it do? And then what is the effect of aging for this particular hormone? So the first hormone, growth hormone. This comes from the anterior pituitary gland, and it actually has actions all over the body. And during development, of course, it's particularly strong effect on bone and muscle. It helps to break down fat, controls things. And of course, as we age, it's really more kind of a maintenance factor, if you will, in that sense. Another one of its targets is the liver, where it causes the release of another hormone called IGF-1 that we'll talk about in a moment. It's the next one I have listed here. Well, what are the effects of aging on growth hormone? Growth hormone follows a circadian rhythm where it's lower during the day and higher at night. And what happens with aging is that kind of flattens out. So instead of staying down during the day and up at night, that up at night kind of comes down a little bit. So there's really not a lot of difference. And it can lead to a condition called somatopause. And in this condition where hormone is really not going up anymore, lean mass can go down and fat mass can go up. And that is, of course, common with aging. That's one reason why it's harder to maintain weight when you get to, say, my age, is because this may already be affecting me somewhat. I don't know that for a fact, but it is certainly always harder as you get older. All right, the next hormone down, IGF-1. I won't tell you what it stands for. It's just extra information you don't need. This comes from the liver, although some IGF-1 can be produced locally at specific tissues and have actions there as well. And then IGF-1 circulates around, and in the body, and this is actually also true in muscle, it increases protein synthesis in many cells. So it works in concert with growth hormone for growth and repair processes. However, specifically in skeletal muscle, remember we talked about satellite cells and their role, and especially with aging and muscle repair. Well, growth hormone can activate, or I should say help to activate those satellite cells. And so it also has an important role in muscle. Well, IGF-1 tends to go down with aging. And that means that repair of skeletal muscle is going to be more difficult. However, there's a lot of literature that also shows the role of potentially of IGF-1 in causing cancer. And so we don't want to necessarily just go and raise IGF-1 all of a sudden without knowing what the implications would be. All right, the next hormone I listed is melatonin. So this comes from the pineal gland that we talked about, the nervous system, and is having a role in circadian rhythms. Melatonin helps to regulate sleep patterns in that we make the melatonin at night. And so it makes us sleepy. Well, with aging, there's less melatonin, and so our sleep can be interrupted just a little bit more. Another hormone here called thymosin. This one you may not have heard before. Thymosin comes from the thymus, which you also may not have heard before. It's a gland that actually sits kind of at the top between the lungs. It's quite large when you're born. And then at about age 20, it starts to decrease in size. So by the time you're 60, it's just a tiny piece of scar tissue. Well, this has implications for the immune system because the thymus is actually where your T cells will mature. And so the thymus releases thymosin, but actually, interesting, comes back to the thymus to help these T cells mature. Well, the thymus, as mentioned here, starts shrinking at age 14, disappears by age 60. That means that we cannot make new mature T cells when we get a little bit older. We still have our existing ones that can respond, but we're not going to make new ones. But this increases the susceptibility to infections and cancer, and of course that is worse over time. All right, next hormone here, DHEA, dehydroepiandrosterone, if I remember correctly. This comes from the adrenal gland and is considered to be an androgen or a male sex hormone. However, as you'll see in a moment, that we don't know a whole lot about it, so we can't say anything for sure. But we do know that it's a precursor to both testosterone and estrogen. This is not unusual because all steroid hormones are interconvertible to some degree. And if anyone raises testosterone levels, they probably also have an increase in estrogen at the same time. If somebody raises estrogen levels, they probably also increase some testosterone at the same time. But the action of DHEA, we don't know. You can find things on the internet purporting all kinds of things about it, but the literature is really all over the place. And so we are still learning. Why do I even mention it? Well, DHEA is the hormone that is higher than any other hormone in the blood. Its concentration is higher than any other hormone in the blood, yet we don't know that much about it, relative to many of these other hormones that have been studied for decades. In addition, the DHEA level falls off a cliff as we age. So it goes from a very high level to a very low level. Well, we know that, so it decreases drastically with age, but what is the outcome of that? We don't know. We don't know. It's really a hot topic for research. It's also a hot topic for people selling DHEA as the next youth, fountain of youth therapy, that you can go take DHEA and it can make you younger. And I'll leave the rest of that to a student presentation on that particular topic. Let me erase these out here so that as we scroll up, we won't have all of these lines. All right, finally, I mentioned testosterone and estrogen, which of course come from the testes and the ovaries respectively. They're involved with maintenance of sex organs, bone, testosterone in particular for muscle. And then, I also mentioned here for estrogen that it keeps HDL, the good cholesterol, high, and the LDL, the bad cholesterol, low. That is a good positive effect of estrogen. Well, how does testosterone change with age? Well, I mentioned here that it's highly variable. And we will come back to that when we do reproductive system, because somebody will be assigned to talk about andropause and to provide some more information on that. But again, highly variable. I've read where it can decrease 1% per year starting, but not in everybody. Some people it stays high, some people it falls like a rock. So it's, again, highly variable. Estrogen is not so highly variable. Menopause is a certainty in women. Again, we'll have a presentation on this, so I'm not going to go into a lot of detail. So it can happen, at a variable ages, but of course, estrogen decreases drastically during that time, so that eventually the only estrogen produced actually ends up being by the adrenal gland instead of the ovaries. Well, because of the protective effects of estrogen against bone loss, and because of the protective effects of estrogen on keeping the good cholesterol high and the bad cholesterol low, then one of the outcomes is actually raising the risk of osteoporosis, raising the risk of heart disease, as well as some other disorders. And this is all happens postmenopausally. Our last hormone is insulin, which of course is manufactured by the pancreas. In muscle and fat, it increases glucose uptake. It moves the glucose from the blood into the tissue, where in fat, it can be stored. In muscle, it could be stored as glycogen. It could be broken down and used in glycolysis, but it's a good energy source for muscle, and insulin helps with that. In the liver, you remember the liver stores glycogen, as well as some other things. And so when you need extra glucose in the blood, the liver breaks down the glycogen and releases the glucose into the blood. Well, insulin suppresses glucose secretion, because remember, if insulin goes up when glucose goes up, and so if glucose is high, the liver does not need to be secreting glucose because it's coming in from the gut during that time. Well, it tends to increase slightly with age. And what that means is it's probably taking more insulin to control blood glucose than it used to, which can be an indication of something called insulin resistance. But again, it's highly variable. So the problem with diabetes does not start with insulin disappearing, not with type 2 diabetes. Okay? And that's why I mention insulin, and that it actually, if it does anything with age, it might tend to slightly increase. So now let's spend a little bit of time on type 2 diabetes. Note that I outlined the problem right here, right up front. The problem with type 2 diabetes is hyperglycemia. Blood glucose is too high. If we scroll down a little bit, I just want to point out that the way I've taught this, and have taught it for years, is I kind of delineate between the symptoms of diabetes and the complications of diabetes, because they're not necessarily the same thing. Right? You can have a symptom that's not a complication. Plus, when we're talking about symptoms, we're typically more talking about early symptoms that might indicate if something is wrong. And some of these symptoms are more prevalent in type 1 diabetes, some are more prevalent in type 2 diabetes, but both types can actually experience these symptoms. Type 2 diabetes, frequent urination. Well, I outline hyperglycemia up top because the frequent urination is because blood glucose is getting too high, and when it's filtered through the kidneys, there's so much blood glucose now that the kidneys cannot pull it all back into the blood, and so some of the glucose is spilling over into the urine. In addition, there's some other things that might end up in the urine, ketones, because you cannot burn the glucose as well. And so now you're having these extra things end up in the urine. Well, by osmosis, water is going to follow along, and they will need to urinate more frequently. There can be unexplained weight loss because of the inability to get glucose into the cells and burn them for energy, so you start to burn your own fat. However, type 2 diabetes can also be associated with weight gain as well, unexplained weight gain. And I'm sorry, I did not have that in the notes here. Frequent hunger, because if you can't get the glucose into the cells don't think they have anything, and you can end up feeling hungry. And then finally, fatigued, again, because you cannot get the glucose into the cells to burn it for energy, so somebody would feel fatigued. Separate those now from the complications, and I will tell you the main complication is this one right here, because it actually explains some of the other complications we're going to read about below. Microvascular damage. It damages small blood vessels. Well, what causes that damage, right? Hyperglycemia, we said that's the major problem, and in type 2 diabetes, that's what we try to control. It's not the only problem, it's not the only thing going on. But hyperglycemia, if you think of glucose, it's sugar. Sugar is sticky. And those sugars start to stick to other molecules, including proteins and so forth. And it can render those molecules less active. It can damage them. And that's what initiates this microvascular damage, is it's connected with this hyperglycemia. And we'll talk in a moment about how we can actually measure some of the how we better measure glucose levels over time. Well, the kidney needs to filter all of the blood. And so microvascular damage in the kidney can lead to kidney problems. And this should say wound healing rather than wood healing. Let's correct that here. Wound healing requires a good blood supply. You can't heal wounds as well when there's not as good a blood supply. And the further you get away from the heart, this is even more true. And that's why diabetics will often have problems with their feet and their legs, is the circulation is poor. And so the wound healing is much worse. It can also lead to heart problems because microvascular damage in the heart can result in, excuse me, an inability to deliver oxygenated blood to certain parts of the heart. The heart might have to work harder, and you can end up having different problems. Retinal damage, because the retina do not have adequate blood supply. Atherosclerosis, which we talked about earlier. More damage on the inside of the blood vessels. This is accelerated in diabetics who have 3 times the incidence of heart disease due to atherosclerosis. They have 3 times greater risk of stroke. And so that's why it's really important, again, that this hyperglycemia be controlled. Right, cataracts are also an outcome of diabetes. They have excess deposits in the lens of the eye. And again, it's thought to be connected to blood glucose levels and some damaged proteins. And then I'm going to make a correction here on this next one. Complications are often the result, remember we talked about advanced glycation end products, not glycosylation, which is the enzymatic addition of a glucose molecule to a protein, but these complications are a result of glycation, where there's so much sugar, so much glucose that it actually starts to stick to the protein or other molecules. HbA1c denotes glycated hemoglobin. Hemoglobin is actually one of those molecules to which the glucose kind of sticks. And this becomes actually a pretty useful measure of how well somebody is controlling their blood glucose. Red blood cells have a lifespan of 90 to 120 days. And so if hemoglobin found in these red blood cells has a lot of glucose attached to it, we know that that person has not been controlling their diet well, because once that glucose is attached, it is staying there. And so the HbA1c level, the glycated hemoglobin, indicates how glucose control has been really over 6 to 8 weeks, which is a lot better than somebody going and getting their blood drawn on one day, because they could have eaten really well for the last 3 or 4 days and look good going into the doctor, but you can't fake the HbA1c level. Prediabetes is now a defined official clinical condition that precedes type 2 diabetes. It's not that all of a sudden one day you didn't have diabetes and the next you do. It's a continuum where your insulin does not work as well, the glucose stays in the blood, and it happens slowly over time. And at a certain level, it would be called type pre-diabetes, and at another level, it would then become type 2 diabetes. Well, in this case, the glucose levels tend to remain a little bit normal, but the insulin levels get just a little bit high. So even with normal glucose, if insulin is higher, it indicates that the insulin the pancreas is having to make more insulin in order to control those glucose levels. And we refer to this as insulin resistance, because we're resistant to the insulin, we're not responding as well to it, or decreased insulin sensitivity, in that we're not as sensitive to the insulin. They kind of mean the same thing. It's just the point of view from which somebody is speaking. So under letter F here, what I'm going to do is going to draw a graph. Is what happens to glucose after you eat a meal. And if you eat a meal, and here's the graph, and here's time, and this is actually the same kind of thing that happens if any of the ladies in the class have have been pregnant and have had the oral glucose test where they give the nasty tasting cocktail and measure blood glucose over time, this is what they're looking at. Only this is if you eat a meal, but the same thing would happen. Glucose starts down here and it'll go up, and then insulin gets released and the glucose will begin to come back down, so that by 4 hours later, your glucose levels are back down to normal. So we'll just write 4 hours. Now what happens in somebody who's diabetic is that they're actually starting at higher glucose levels, right? They start with higher levels. It goes up higher, and it does not come down after 4 hours. So it remains high even later because their insulin, even though insulin is being secreted at a very high rate, it is still not able to handle all of the glucose. Now, the next thing down on your paper is the insulin response following a meal. And what I'm going to just do is draw it on the same graph, and I'm going to do it in green. So the insulin response would be something like this for normal. Right? I probably made it come down a little bit too fast. But in a diabetic, right, insulin levels are staying high, and yet they can't get rid of the glucose. This is the idea behind insulin resistance. The real problem is not that there is no insulin. Insulin levels are actually high, but they're not working anymore. Although over time, the beta cells, beta cell burnout, they get to the point where they may not be able to secrete insulin anymore, and that actually might be due to damage from the hyperglycemia. So we'll skip that little graph for insulin response. Well, how is then diabetes treated? Well, medications. We know it's not the first thing anyone would want to do. The exercise and the diet down here would come first. But the reality is that many doctors don't believe their patients will adhere to an exercise or diet program. And many patients indeed won't. But it's always better if somebody does. And I didn't list all of the medications here, but insulin can be used if it has to. That's always the last thing you want to get to is insulin, but there are other drugs that can help control blood glucose levels. One of the ones that's out there, metformin, will actually suppress the release of glucose from the liver while also helping to make insulin, improve insulin sensitivity. And so it can be effective. And there's a number of different drugs that'll do that. Exercise. Why does exercise work so well even without weight loss? Because exercise by itself can actually act like insulin and get the glucose into the muscle. In addition, exercise increases insulin sensitivity. The catch here, though, you have to exercise regularly. You have to get up off the couch and be more active regularly. And it works better in combination with a diet that's controlled better. Why does diet work the best? Well, because if we eat properly, we actually improve glucose control, independent of any medications. And I am not a big proponent of everyone has to lose weight to be healthier, because I don't believe that everyone has negative health consequences from carrying excess weight. However, there are certainly some individuals who do benefit, and diabetics, usually with weight loss, if they can diet and exercise to do that, can improve insulin sensitivity. And the idea, remember, in the end, is to control blood glucose levels, controlling the hyperglycemia to reduce all of the complications. That's the goal. I only list 2 risk factors here. And yeah, technically you could look at anything and say about the same thing, but family history. Family history can be a strong indicator of the risk for type 2 diabetes, particularly if you have a parent, a sibling, right? So first degree relatives. Second degree relatives, an uncle, an aunt, a grandmother, a grandfather, a cousin, that does increase risk, but it doesn't increase it nearly as much as if your parent or brothers and sisters have it. And then lifestyle. Whether this is completely true or not, I once had a dinner with somebody who I value his opinion highly, but he was also very opinionated, said that if everyone would exercise and eat the way that we were supposed to, we would not have any type 2 diabetes. that we would be able to completely eliminate it. Now, it depends on the individual, I think, because in some cases, family history is quite strong. And in those cases, those individuals need to come back and do the exercise and diet, regardless of whether they have diabetes or not. It's going to be helpful for them. But the fact remains that type 2 diabetes is a modern day disorder. Yes, it did exist before, but the rates have, more than gone up just a little bit. And it parallels things like sugar intake, which compounded with, the move from an active society to sitting at desks for jobs, I think has had a profound impact on the rate of diabetes. I think that's all that I have. And so I'll go ahead and conclude this short lecture.